In Climate Watch, data shows that the U.S. is hotter than it's ever been. The National Oceanic and Atmospheric Administration released its 30-year new normals Tuesday, which reveals that the country has warmed by nearly 2 degrees over the past 100 years. The new average temperature is now over 53 degrees. Joining me now for greater understanding is CBS News meteorologist and climate specialist Jeff Beradelli. Jeff, how significant is a 2-degree Fahrenheit increase in average temperatures? How alarmed are you in hearing this news?
Well, first of all, I know that the United States has warmed by 2 degrees because I follow this stuff every day. But I think why this story is garnering a lot of attention right now is because of that map you see right there, the United States blood red. Now, what this is a comparison of temperatures from the early 1900s to temperatures in the early 2000s. And you can see basically the whole country has warmed up. It's warmed up more in the west and more in the north, and not quite so much across the Gulf of Mexico. But just looking at that map in these new NOAA climate normals is alarming. So 2 degrees, is it important? Well, I would say if your body temperature goes up by 2 degrees, it is important. So it's kind of equivalent. The Earth has a fever. The Earth system is just as sensitive as your body system. So your temperature goes from 98.6 degrees to 100.6 degrees. You're not feeling too good. You know, you're in bed. But we're expecting to go up another 2-3 degrees, which means that at some point in the next few decades or several decades, we'll have an equivalent Earth temperature to our body temperature of around 102 to 105 degrees. At that point, systems begin to break down. So that's why that comparison makes sense, because, you know, on the Earth, there are so many interconnected systems. If one or two begin to fail, then like dominoes, everything begins to fail. That's what we're concerned about. When you raise temperatures by just a couple of degrees, the averages by just a couple of degrees, you increase the extremes by a lot. So extreme hurricanes, extreme flooding, you know, which we've had recently, extreme fires, extreme drought, which we're seeing in the West more often. All those things will happen a lot more when you shift the normals by just a little.
Jeff, I'm wondering if you can tell us a little bit more about the process that NOAA uses, because they measure the average temperature increase based on new climate normals, and they do this every 10 years. Tell us more about that.
So it's kind of a nerdy thing, and normally, you know, 10 years ago, 20 years ago, this wouldn't have even made the news, but, you know, because of what we see behind us, it's something we need to talk about. The reason why you shift the normals is because the climate changes, right? So either due to natural variability or increasingly because of human-caused climate change, and you have a new baseline. So when I'm doing the weather on air and I'm saying it's 55 degrees today, but the normal is 70, you have an idea that it's much below normal. So we shift them because there's a new reality just to keep up with the times. But a lot of climate scientists don't like it, because as you shift to a warmer normal, it doesn't seem like climate change is as bad. If you were to compare the normals, or what's happening today, to the normals before we started heating the climate back in the early 1900s and 1800s, you would see a much more marked difference in where we are right now to where we should be without human-caused climate change, which is produced by the burning of fossil fuels and the release of heat-trapping greenhouse gases.
So, Jeff, we've been focusing on the United States. I'm wondering, are some parts of the world warming faster than others?
Sure. So the U.S. is kind of keeping pace. It's slightly behind in the warming. We've gone up around, you know, you mentioned it, 2 degrees since the beginning of the 1900s. That's about what the world is, on average, has gone up. But U.S. specifically, about other regions, yes. There are some regions that are warming much faster than others. And one in particular is the Arctic region, where all the ice is warming at around 3 times the pace of the global average. And so a lot of it kind of depends upon where the ocean is, you know, if you're near an ocean, if you're not near an ocean, if there's ice, if there's not ice, if there's feedbacks in your local region. And so that's why different places warm at different paces.
And Jeff, we can see on this graphic of the United States that some areas in the U.S. are warming faster than others. I'm wondering if you can tell us a little bit more about why that is. And also, that report shows that eastern and central parts of the country are getting more rain, while western states are actually getting drier. Explain that to us as well.
Right. All right, so you can see, first of all, temperature-wise on this graphic that the west and the north are warming more fast, or faster, if you will. And that's because it's drier. Whenever the atmosphere is drier, it just heats more rapidly. I don't want to get too much into the details here because it becomes very wonky, but basically kind of like a desert, right? It warms up more during the daytime. The sun goes into heating the atmosphere rather than evaporating moisture because there is no moisture. However, in the south, you can see by the Gulf Coast right there, there's more rainfall, there's more moisture present, and because of that, a lot of the energy that comes in, the extra energy that we're trapping due to greenhouse gases, that goes into actually evaporating that moisture and causing more rain. Okay, so with that said, you asked about precipitation. Well, it's drying out in the west. Part of that is because it's warming up. If you evaporate more moisture, the ground becomes drier. If the ground's drier, it doesn't have as much moisture to push up and form clouds in the western United States. So they say drought begets drought. It's kind of a positive feedback loop. In the east, more moisture is coming out of the Gulf of Mexico. It's warmer. The Gulf's warmer, so there's more evaporation. There's more rainfall. Also, the atmosphere is warmer, so it can hold more moisture, and so a lot more rainfall falls to the east of the Mississippi River. So as you warm up in the northern tier of states and in the east, because you have that inflow of moisture from the Gulf of Mexico, and more of it, it's raining more, which is exactly what we expect and what our computer models, by the way, have said for decades now about man-made climate change.
All right, Jeff, thank you.